Cisco offers two SD-WAN solution. One is based on Meraki and the other one is based on Viptela. So Meraki SD-WAN is also one product that Cisco offers, and the other one that they offer is Viptela. So Viptela was a company that used to offer the SD-WAN solution earlier. Then later on that Cisco acquired Viptela. So now it has become Cisco SD-WAN Viptela or just Cisco SD-WAN solution. So we are going to talk about Cisco Secure SD-WAN as the part of the official content, as a part of the official certification exam. Just in case if anyone is preparing for the certification exam, they need to prepare for the ENSDWI, right? So implementing Cisco SD-WAN solution. The name of the exam is ENSDWI. Exam code is 300-415. And this is what we are going to cover as a part of our content. We are going to cover ENSDWI, exam code 300-415, version 1.1. Right, so the version that is currently in effect is version 1.1. We are going to talk about that. What is the content? What we are going to cover? First of all, let's talk about the agenda, like what we are going to cover as a part of our content. So the entire content that we have, that we are going to cover, it is divided into several sections, such as first section is going to focus on the SD-WAN architecture. Second section is going to focus on the controller deployment. Third section is going to focus on the router deployment. Fourth section is going to focus on variety of policies. Fifth section is going to focus on the security and quality of service as a part of our, and the sixth part is going to focus on the management and operation. Right, so we have like total 6 parts, like in which the content is going to be delivered. Like we have total 6 chapters, total 6 modules in our official content. Like as per the exam ENSDWI, we have total 6 parts, 6 chapters, 6 units that we have to cover, starting from the architecture all the way to the day 2 operations, which is just basic management. Right, so in total 6 parts, we are going to cover our entire SD-WAN content. First part, that is the architecture part, is going to focus, this part is going to focus basically on the SD-WAN architecture and the components, like what are the components that make up the Cisco SD-WAN solution. Again, we will be focusing on Viptela based SD-WAN. We are not going to focus on the Meraki based SD-WAN. So Meraki is also one product that Cisco offers, SD-WAN solution that Cisco offers. We are going to focus on Viptela based SD-WAN. SD-WAN architecture and components. What are the SD-WAN architectures and components? Like different components used in the Cisco SD-WAN, such as vBond, vManage, vSmart, vEdge, options and the concepts related to the vEdge, such as TLock, IPsec, vRoute, BFD, and all. So these are like architectural components that we use in the SD-WAN to create an SD-WAN network. So we will talk about that, like from the orchestration plane, management plane, control plane, data plane, and all that. Then we'll talk about like what type of these are what we refer to as controllers. These things is what we refer to as controllers. We'll talk about that just in a moment. These things we refer to as controller. So vBond is a controller, vManage is a controller, vSmart is a controller. These three things are what we refer to as the controller, and these are the routers. These are the WAN edge routers. These are the routers like that we are going to deploy at the edge of our campus network. So like vEdge, cEdge, like what is this vEdge, what is this cEdge, what are these routers, what operating system they run, how to configure that operating system and all. We'll talk about that. So from the architectural point of view, we need to talk about 2 things. We need to talk about the controllers, and the second one is what we need to talk about the edge devices. Right, so controllers like something called vBond, vManage, vSmart, and the edge devices such as vEdge and cEdge. Remember that V stands for Viptela. Like I said earlier, before Cisco took over this Viptela company, earlier Viptela was a dedicated company that used to create the SD-WAN solution. Later on, it was acquired by Cisco, so now it has become Cisco SD-WAN. Right, so this V here stands for Viptela. So vBond, Viptela Bond, Viptela Manage, Viptela Smart, vEdge, and C stands for like as usual Cisco. So this is cEdge, vEdge. So anywhere you see the keyword V stands for Viptela. Like for example, vRoute, so Viptela routes and also. And C stands for Cisco. So as you can guess, like here we have 2 types of routers. We have Cisco operating system, Cisco IUS based router, and we have Viptela operating system based router as well. We'll talk about the onboarding of both of them in our lab environment. Then how the SD-WAN is going to deal with the like, cloud services, how this Cisco SD-WAN solution is going to deal with the cloud services, how if we have deployed some applications in the cloud, if we have deployed some infrastructure in the cloud, if, for example, we have a shared data center, how we can extend our SD-WAN to these applications that we have deployed in the cloud, how we can extend the capabilities of our SD-WAN to the infrastructure that we have hosted on the cloud, and how can we extend the capabilities of our SD-WAN in the shared data center in the co-location center. This will complete, like once we are done talking about all those things, this will complete the architectural point of this Cisco SD-WAN. Once we are done discussing about this SD-WAN architecture, then we'll talk about deployment of the controller. How can we deploy the controller on premises, like in your data center, in your headquarters, somewhere in your network, and how can we deploy the controllers on cloud? So we will talk about here, like once we are done with, once we are done talking about these basic concepts, then we will talk about from the architectural point of view, how to deploy the controllers, controller deployment, and the router deployment. Controller deployment, like how can we deploy the controllers on cloud, and how can we deploy the controllers on premises? So describe the controller cloud deployment and on-premise deployment, like how much RAM you will need, how much CPU you are going to need, how much SSD you are going to need to deploy the controllers on your premises, and what is the requirement, what are the requirements if you want to deploy the controllers onto the cloud. Then once we have deployed the controller, how the connections between the controllers will come up, what is this certificates, what are these certificates, how the certificates are going to be installed and all. So the point is that once we have deployed the controllers on the cloud, either on the cloud or on the premises, we also need to install some certificates on these controllers so that they can authenticate each other and so that they can form some sort of connections to each other. So right here, we will talk about those certificates that are needed. Like we will talk about the certificates that we need to install on the controller so that they can talk to each other, so that they can build some sort of connections to each other. And if the connection is not building up, then we will try to troubleshoot. We will talk about some generic commands, some general commands that we are going to use to troubleshoot the connectivity between the controllers. Right. So this section number 2 is specifically going to focus on the controller deployment. And similar to that, the third section is going to focus on the router deployment. Like what is the WAN edge router, like what is the Viptela operating system based router, and what is the Cisco IUSXE like SD-WAN based router. So Viptela operating system based routers are what we refer to as the VH router, and Cisco IOS XE SD-WAN based routers are what we refer to as the CH routers. So earlier Viptela was the company that used to create the operating system. When the Cisco acquired, they improved the functionality of the iOS XE and they integrated the XE they added the SD-WAN capabilities in the same. So CH, like CH, Cisco iOS XE SD-WAN based routers are what we refer to as the CH router. So we'll talk about deployment of the VH router is different than the deployment of the CH router. The way we deploy the VH router is completely different than the way we used to deploy the CH router. So we will talk about the deployment of both of the WAN edge router. And we will also about this process called ZTP, zero touch provisioning, or also referred to as PNP or plug and play. This process ZTP and PNP allows you to onboard a VH router or the CH router in like an automated fashion. Like minimum to no user or admin intervention will be required to onboard these VH or CH devices. Like the maximum to maximum what administrator might need to do, that the administrator has to unbox that router. The administrator has to plug in that router to the some sort of wall socket. The power supply basically they have to give, and they have to give this router a connection to the internet. That's it. They don't need to configure anything on here. When the device comes up, device can use this PNP or ZTP process to get onboarded in your SD-WAN network in an automated fashion with minimum to no user intervention, minimum to no user interaction required. So we will talk about how this ZTP or PNP process works to onboard VH or CH devices. Right, and different types of deployment, such as how can we deploy the routers in the data center, how can we deploy the routers in our like regional hub, headquarter, branches, and all that. Then the once the routers are connected to each other, once the routers are deployed in the network, they are going to form some connections to each other as well. So we'll talk about those connections. We'll talk about different types of tunnel, what is underlay, what is overlay, circuit termination, something called T-lock extension and all. So from the router deployment, once the router is deployed, then we'll talk about different types of tunnels that the router actually builds. And just in case, again, if you are facing some issue, then how to troubleshoot those problems related to the tunnels. Also, here itself, we are going to talk about the routing. We will talk about different types of routing protocols that are supported in our SD-WAN scenario. Like what routing concepts are supported on the vEdge and CS devices, we will talk about here. Like vEdges, and I'm just going to refer to them as WAN edge. So what routing options are available on the WAN edges, such as like OSPF, BGP, EIGRP, static routing. We will see how to configure OSPF, BGP, EIGRP, and static routing using CLI and using something called template. So just like we configure a typical router, we configure functions on a typical router like OSPF, BGP, EIGRP using CLI. We can still do the same here as well. And the command line interface is pretty much similar to the Cisco, like iOS command line interface, very much similar. In fact, a lot of commands are exactly the same. So it will not be very challenging to work on the command line interface. But the main power of the Cisco SD-WAN comes from this template. Like we are going to create one configuration template, and we can push this configuration template maybe on 1,000 number of devices, so that we don't need to do the same configuration again and again on 1,000 number of devices via CLI. So we will talk about like how can we push the configurations with the help of the templates and all. What is OMP, what is T-lock, and all that we will talk about. So by the end of like these three sections, we will have completed like the routing. We will have the end-to-end reachability in our topology between any two end machines. Like everything will be up and running. Up to this point, up to section 3, we will be done with all the controller deployment, router deployment, the concepts of the SD-WAN, like controllers, routers and all. Then the connectivity between the routers and the controllers, connectivity between the controllers and controllers, connectivity between the routers and routers, then the routing protocols and all that, HSR, VRRP and all that. So by the end of these 3 sections, our in this topology, our routing and everything will be up and okay. Like we will have like everything configured up to these 3 sections. We will have like end-to-end reachability from anywhere to anywhere. We will be able to do ping and trace from one point to other point. And then we will be able to move on to the next section that will focus specifically on policies. So policies basically means once your SD-WAN network is up and running, once you have the reachability and to end from one point to other point, then you might want to change the way the traffic is flowing in your network. You might want to, let's say, for example, I want that whenever the user sends the traffic from site 1 to site 2, it must not go directly. It must go via the data center, and then from there it go to the site number 2. So maybe we want to influence the way the traffic is going to flow from one point to other point. Maybe we want to restrict, like on this router, I want to restrict that this router must not learn some routes. Maybe I want to have some sort of hub and spoke type of topology. So basically the policy section focuses on these things. In the policy section, we are going to focus on different type of policies that affect the routing and that affect the data traffic. The policies that affect the routing decision is what we refer to as the control policies in the SD-WAN. We'll talk about that. And the policies that affect the data traffic is what we are going to refer to those as data policies. So policies are going to focus how the routes are learned and advertised in the SD-WAN network. And the data policies are going to focus how the data traffic is going to flow in the SD-WAN network. Remember that certain objectives can be achieved, like you can achieve certain things with the help of both like control policy and the data policy. Like let's say, for example, there is a task. That task says that the traffic from this point to this point must go via data center. This thing can be done with the help of the control policy as well as the data policy. So certain objectives can be completed with the help of like both the policies. However, remember that control policies specifically are going to change the routing behavior, and the data policies are going to change the data traffic. Right, so we'll talk about these policies, then VPN segmentation, hub and spoke type of topology, full mesh topology, partial mesh topology, different types of topology. Application aware routing means like we have some business critical application, and I want that for that business critical application, a path should be chosen that has low loss, latency, and jitter. So application aware routing basically means that for certain application traffic, I want to prefer a path that has low loss, latency, and jitter. So I can configure this thing called app aware routing, application aware routing, where your SD-WAN can continuously monitor the loss, latency, and jitter on the path, and it is going to choose the path with the low loss, latency, and jitter for certain application traffic. So that is what we refer to as the application aware routing. We will see how to implement it. Central breakout and the local breakout, basically like regional internet access and direct internet access. We are going to talk about that. Maybe for example, for every branch, I want that internet should be provisioned from the data center. Like everything should go to the data center, then from data center it should go to the internet. But for this particular branch, because here we have some like a lot of guest users, I want for the guest users, DIA should happen, direct internet access should happen. When the guest users send the traffic to this managed router, this managed router should be able to send that traffic directly to the internet without sending it towards the data center. So things such as DIA, direct internet access, where we are going to actually allow the traffic to exit directly from the router to the internet, not being sent towards any data center for any sort of monitoring or anything. So configure and verify DIA, direct internet access. Right, so we'll talk about the policies. Once the policy section is done, then we will enforce the security in our SD-WAN. And when it comes to security in the SD-WAN, we have things such as service insertion. Service insertion basically means, let's say we have a firewall in our network, and I want our SD-WAN network to be aware of this firewall. Maybe I want when the traffic from site 1 to site 3 is to be sent, like I want, if the user is sending the traffic from site 1 to site 3, it must be sent to the firewall first of all for inspection, and once everything is okay, then it should be sent towards the site devices. So service, like we have such as, for example, a firewall, such as, for example, a load balancer, such as, for example, IPS, IDS. We have a service available somewhere in our site, and I want that service to be available for the SD-WAN network for the traffic. So that can be done with the help of this service insertion. Service insertion and chaining allows us to send the traffic from one particular site to other particular site towards a particular, let's say, for example, firewall, load balancer, IPS, IDS, like any type of service that we have added. If you do not have a dedicated firewall, dedicated IPS, IDS device, then we do have the option that in iOS XE SD-WAN, basically in the CH devices, we can implement all of these features natively on the box itself. Like we will not require a dedicated IPS, we will not require a dedicated like a firewall, we will not require a dedicated like AMP thread gate, like we will not require a dedicated appliance to enforce the security in our branch. If we have a small branch and we want to have some sort of security for that particular branch, we can enforce the security directly on the box itself. Like we can enforce the application aware firewall, IPS, URL filtering, AMP, SSL, TLS proxy, AMP and thread grid, a DNS security, secure internet gateway. We can add on all these security related things on the box itself. We will not require a dedicated hardware for the same. Remember that these functions are going to be very limited. However, it's not like you will be able to do everything that you can do on a typical IPS or a typical, let's say, for example, a firewall. The functions are going to be very limited. But from a small branch point of view, they are going to be sufficient. Like you will not need to deploy a dedicated device for the same. right? So for a small branch, we can actually add on the security on the branches directly on the box itself. We do not need any specific hardware for the same. So we will talk about, like, although it says describe, that means we don't need to do it practically, but we will see like what things we can do in practical, and we will try to create a policy for the same. We can use the similar zone-based firewall type of thing here in SD-WAN as well, but again, the functions are going to be very limited. Like, the things that we call zones in terms of firewall, such as zone inside, zone outside, DMZ and all, those concepts might not be available exactly the way like they are in the traditional one here. So here we are going to refer to different things as a zone, and we are basically, when we say zone-based firewall policy, we basically mean that we are going to apply the policy for a certain type of traffic that goes from one VRF to other VRF. We'll talk about that, but it's not going to be exactly the same. It is not going to be exactly the same as we have in the traditional network. Like, it's not exactly the same, but yeah, we have the option of the zone-based firewall. We do not need any dedicated firewall for the same. This function is available on the VH and CH, both. Like, it is available on VH and CH both. We can apply the zone-based firewall policy both on the VH device and the CH device. Again, it is not going to be exactly the same. In fact, these security features might not be exactly as robust as much. They might not give as much features as in the typical, like, firewall typical devices, but in a small branch, we can enforce the security based on these native features, and they work pretty well actually. Right? Then once we are done with the security, again, remember that as a part of our content in security, we only need to configure the service insertion. Rest of the things are only describe, but we will see like how much lab we will do. Like, we can do this lab, 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 we cannot do this lab because that will require the umbrella subscription and all. I will show you how to do this, but we might not be able to do that lab in our environment. Same goes for secure internet gateway as well. But most of the labs we will be able to do in practical. So we will see that. Once it is done, then how to enable the quality of service in your SD-WAN. Once it is done, once you have configured all that things, then we will talk about how to enable the quality of service on the WAN edge router. Maybe I have some audio video traffic, and I want that audio video traffic must be prioritized over the typical data traffic. So how can we add on the quality of service functions in the SD-WAN? That we are going to talk about in the course, in the quality of service, scheduling, queuing, shipping, policing, marking, per tunnel quality of service, and also configure and verify quality of service on the WAN edge router. So we will see what are these concepts in terms of quality of service, and how can we configure these quality of service concepts on our WAN edge router. Okay. And finally, this will complete actually everything that we need to know from the content point of view. At the end of the section 5, we will have our SD-WAN network up and running. We will be done with the different types of policies and all. We'll be done with like security policies. We'll be done with the quality of service concepts. By the end of these 5 sections, we'll be done with our content. And in the 6th section, we will just focus on the management and operation, day two operations, basically. Monitoring, like how we can use the vManage dashboard to monitor different things, authentication, reporting, how we can, what is this API, and how can we use the application programming interfaces to do the same things that we have done with the help of GUI. So whatever things you have done from the GUI can also be done with the help of APIs, application programming interfaces. So we will try to, do some basic API calls, and we will see like what things we can do from the API point of view as well. Then how can we upgrade the software images and all of the WAN edge routers from one point? We'll basically just some general day 2 operations, some tshoot commands regarding the control plane, data plane, and everything will come under the day 2 operation. So this is like the complete content that we are going to cover. From the content point of view, this is what we are going to cover. Architecture, controller deployment, router deployment, policies, security, quality of service, management and operations. Total 6 units we need to cover. And these are the labs that we are going to cover. The lab will remain like this. I will explain you the lab when we start the lab. So basically, just to give you the idea, we have a data center where we have deployed the controller, we have made the reachability, then we have a few branches, a branch where 2 edge devices are there, a branch where 1 edge device is there. In a data center as well, also we have the edge device. Here we have a few devices sitting behind the NAT. Here we have MPLS transport, here we have internet transport. So basically, this is the lab that we are going to do. This is like the topology where we are going to do the lab. And these are the labs that we are going to do. We will cover is like approximately 45 to 50 small labs we will cover, starting from like how to connect all these SD-WAN controllers, like edge devices, basically interconnecting the SD-WAN components, installing the enterprise root CA server, configuration commands on the CLI, then GUI, then vBond CLI, installing the certificate. So once we have done the initial configurations on the controller, then how can we add those controllers onto the vManage, and how can we install the certificates and all. So this part like 3, 4, 5, 6, 7, 8, this will focus on controller deployment and certificate installation on the controller. Then the VANEDGE deployment, vEdge, CEdge, CLI, GUI, and how to install variety of certificates on these vEdge, CEdge devices. Right, up to this point, we'll be done with controller deployment. We'll be done with the VANEDGE router deployment. You will notice at the end of this point, all the devices, all the edge devices will have the reachability to the controller. They will be able to talk to each other and all. So that part will be done here. And then we will focus on our the main concepts of the SD-WAN in terms of templates. Like what are these templates? How can we configure different types of templates and all? System template, banner template, VPN, and all these different types of template. We will talk about that here. Then the routing, static routing, OSPF, BGP, EIGRP using CLI and the graphical user interface GUI. We will talk about all these routings via CLI and GUI both. Right? We will create different templates for OSPF routing, BGP routing, EIGRP routing, and then we will add those templates onto the devices. Once it is done, we will verify the reachability and all. So by the end of these labs, we will have complete end-to-end reachability in our SD-WAN topology. Additionally, a concept called TLOC extension. We'll talk about that later. So by the end of these labs, like approximately these small 20-25 labs, we will be done with our routing section. We will have end-to-end reachability in between any 2 devices in our lab topology. Right, and then we will focus specifically on the policies. We'll talk about policies, control policies such as hub and spoke, traffic engineering, service insertion and chaining, route filtering, TLOC filtering, route leaking, VPN membership. We want to prefer MPLS over internet, application aware routing, NAT, DIA, CFLOT, POS, packet loss mitigation. Like control policies and data policies, we'll talk about approximately 10 control policies and data policies. Then policies regarding the security, application aware firewall, IPS IDS, URL filtering, AMP, DNS, web layer security for DNS. Like these are the policies that we will talk about from the practical point of view. These comes under the security policies. Then how can we add our SD-WAN network to the cloud? So cloud on-ramp for software as a service, cloud on-ramp for infrastructure as a service. There is also cloud on-ramp for co-location. Cloud on-ramp is a feature. This is a feature that they have in our SD-WAN that allows us to connect our SD-WAN to SaaS applications, to infrastructure as a service, and also the co-location centers, shared data centers. So cloud on-ramp feature, how can we configure for these different types of applications? We will talk about that. And at the end, some generic day-to operations, such as we will explore variety of monitoring tool, monitoring features in our vManage. We'll talk about like syslog, TCP dump, API documentation to create an API call to query the vManage. We will see some basic API calls that we can do from our browser to the vManage, and we will be able to do the same things that we have done from the GUI via API as well. And then how can we upgrade the software images of the edge devices and the controller from the vManage itself, a centralized point from where we can do all the software upgrades. So again, 45, 50 small labs we will be completing in this same topology. Like in this topology, we have two transports, we have a data center, we have a few branches. In some branches, devices are sitting directly at the edge. In some branches, the devices are at the edge, like they are sitting behind the net and all. So in this topology, we'll be able to complete all the things, all the labs that we have explained here. Right. So this is what we are going to cover as a part of our content. If you guys have any doubts, you can ask from the content point of view, not like what is SD-WAN and all. If the content point of view, if you have any doubt, you can ask. Yes, Devashish, you can unmute.
Sir, I joined 10 minutes late. So regarding this lab, will you means where are you going to do in EVNG or?
Now that we will talk about. That we'll talk how to do this lab and all. We'll talk about just in a moment.
Okay.
Right. This is like what content we are going to cover as a part of the official Cisco certification exam. These are the things that we will talk about. These are the labs that we will do. How we are going to do this lab, we will talk about that just in a moment.
So anything related to debugging?
Sorry.
Anything related to debugging techniques using CLI or what all things to check?
I can give you some commands, some generic commands. Ideally, like packet captures and those things can be done from the vManage itself. We can do the packet captures from the vManage and get the output, export the output in the PCAP file and all. So that can be done. I can tell you some generic commands, but for the debugging, but generally we are not going to enable these debuggings in a production environment. I will tell you like different like packet capturing concepts that we have in the vManage itself. That will be helpful.
Okay.
No, we are not going to. You will not use any proxy, solutions such as Zscalers. We are also not going to use any load balancers such as F5. In fact, this is not even a firewall. This is not even a firewall. This is just a router. So, right, it is just to simulate like, okay, this is a firewall. This is a firewall. So we are not going to use any like concepts such as like F5 load balancer or Zscaler. I will tell you like how the integration and those things are going to happen, just in case if you are interested in. But practically, as a part of our content, we are not going to cover it. Maybe at the end of the classes, like at the end of the classes, if you are still here, then we can discuss about those things. Any more question? Anyone? Any doubts? If you have, let me know from the content point of view. Anything? All right, then. So let me tell you how you are going to do this lab. Like there are two ways. Like you can access this lab. Either like if you have yes, this content is inclusive of every topic that we have in our CCI. So yes, like this content is enough. This is like a very small part of this content is there in our CCI routing, CCI enterprise infrastructure. So this will complete. This will also include all the things that we have in the CCI exam. Yes. So there are two ways you can use to actually do the labs, do the practicals in this lab. One thing that you can do, one thing that you can use actually is to like you can use this cloud-based lab that will be given to you from here itself. So this is like one lab solution. Yes, all these topics cover the CCI enterprise infrastructure SD-WAN topics related to the SD-WAN that we have in CCI enterprise infrastructure. It is covered here as well. Okay. So one way to basically do the lab is to use this portal. You will be given the access to this portal from here itself, like dc.mylabs.cloud. So you can just log in here with your credentials, and then you can just start doing the lab. So maybe something like that. So for example, you once you log into this lab, once you log into this portal, you can just open this lab, and then the same lab you will get here as well. This is the same lab that you have here, and you can practice on this lab as per the requirement. You can power on the devices and all, and you can practice on this lab. You can like power on all devices, wipe and everything. So you can do all those things here. You can use this platform, this dc.mylabs platform. You can use to practice all the things from the lab point of view. This is one thing you can do. This is one way, one approach to do the same. The second thing is that if you have a well-equipped machine, you can build this lab at your home environment as well. You can build this lab completely on ENG. So if you have a good resource machine, you can build this lab, or I can share you the UNL file for this, and you can build this lab at your home machine as well. So of course, you will need some images of the routers, like of these like controllers and all. But in ENG, it is also possible to build this lab. Remember that you need to have good resources for the same. If you are, see, there are different versions of the controllers and the S devices. In fact, just to give you the idea, if you go to software.cisco.com and log in there, let me show you quickly. So if you visit this software.cisco.com, and let me just quickly log in. So if you go to software.cisco.com, you will get the idea what is the current version of the SD-WAN that is going on. They continuously, improve the performance, they continuously add different features in the SD-WAN, and they release it as a new solution. So you can go to Cisco Software Central, software.cisco.com. You can go to downloads and upgrade. And here you can search for the SD-WAN, and you can see like what SD-WAN solution, what SD-WAN version is currently going on. 20.11 is currently in the market of the SD-WAN solution, right? So you can access this software.cisco.com. You can go for like, you can search like SD-WAN here, right? So you can search like, for example, SD-WAN here. Once you search this SD-WAN, you can see the like here, you can, from here you can download the controllers images and everything. So for example, you want to download the controller image, you can click on this vManage software, and it will open the version. So you can see that 20.11.1.1 is the latest release for the SD-WAN. However, it is an early deployment. ED stands for early deployment. Stable release is still 20, like mid deployment. So this is the recommended release. This is the recommended release. Recommended release is 20.6.5, 20.3.5, but the latest release is 20.11. Right, we will either be practicing on 20.11 or 20.10 because the GUI and everything is quite different in both. So we will either be practicing on 20.10 or 11. These two have the similar GUI, but 20.56 they have very, like, different kind of GUI. So we will either be practicing on 20.10 or 20.11. Remember that both are in early deployment phases, so quite a lot of bugs and those things will be here. So as per Cisco, they recommend that you go for like 20.6.5.1. This is the recommended release for them. But if you want to practice on it, like latest version, latest release of the SD-WAN, this is the latest release of the SD-WAN. Now, as you can see here, it is 4 GB in size. This is 4 GB for vManage. This is 4 GB OVA file for the vManage. Similar to that, you can go for the vSmart, and 20.11 version of the vSmart. You have to download, and it is going to be approximately like 177, 300, 400 MB in size. The point is, like, if you download all these images from here and you try to run it in software such as ENG, it will just work fine, no problem. You can just go on this you can just go on this vManage, download this QCOW file, and just run it in the ENG. It will just work fine. You can refer to the I believe there is Viptela image set ENG. You can search for Viptela image set ENG. You can open this document and you can follow the steps that they have mentioned in this document to create, like, to add on the devices in there, right? So if you want to build the lab at your home, you can build the lab at your home as well. However, remember this is based on 19 point something. So again, just to give you the idea, if you are going to build an SD-WAN lab at your home, or if you are going to work on the same lab that we have just talked about, it will require like 4211 approximately 8 CPUs will require. Approximately 8 CPUs will be required for you. And the RAM, you can see 16 gig RAM, 2 gig, 1 gig, 1 gig. That means 16, then like 18, and then like 19 gig RAM. And you are not going to have only one VH router. You are going to have at least like 3 or 4 VH router, as we can confirm from here. Where is that? So in this lab, for example, if you see how many S devices are there, so you will find that total 5 S devices are there. So 1, 2, 3, 4, 5. So 5 S devices are there. Every S device will consume 1 GB RAM and 1 CPU. So 1, 2, 3, 4, 5 core will be required here. 5 GB RAM will be required here. So, and then we have a CSR router that consumes approximately 6 to 8 GB RAM, 2 core and all. 32 plus gig RAM you will need to have to run this SD-WAN lab smoothly in your environment. If you have like 32 plus gigabit like gig RAM in your laptop, desktop, any compute machine, server, wherever, and you have approximately like, let's say 8 to 16 core in total, then you will be good enough, like it will be okay for you to run this lab in your home environment. Approximately, as per the office, this is version 19 and we are talking about version 20.11. It will require more CPU, it will require more RAM, it will require more hard disk space and everything. So if you have like approximately like 32 plus gigabit RAM, then you will be able to build this lab like on ENG. There are plenty of tutorials on the internet nowadays. You can follow those tutorials, you can follow this guide to deploy the images onto your ENG machine. As per this, looks like 32 plus gig RAM will be required. But if you go for like newer version 20.11 and all, even if you set the same resources, if you have 32 plus gig RAM, it will be okay for you to run. Right, so 16 core, total 16 core, and 32 plus gig RAM if you have. SSD is recommended, that because in SSD speed and everything is quite fast. So SSD is recommended. So if you have these things, you can run this in the ENG platform itself. 40 gig will work fine. You can try to implement it on the ENG. It might work. See. Right here, almost. vManage node version 20.x and later requires 24 gig RAM. So 24 gig RAM it will require. So 24 gig here, then 2 gig here, then 1 gig here. So 24, 20, 24, 26, 27 gig RAM for the controller, and then 5 number of S devices. So 5 that, like the 32, and plus 8 gig approximately for the CSR router. So 40 gig approximately it will go. So see, like you can deploy these, you can try to lower the RAM, lower the CPU utilization CPUs. You can try to do some testing, and if it works, then it's okay. Otherwise, you can always do the lab on this cloud delivered portal. The access to this portal will be given to you from here itself. So once you get the details, you can log into this portal and you can, start the practice and all. No, 8 logical processors will not work. Like total like 8 physical processors, if you have like total 16, like it will be okay. In 8 logical processors, too much load will be there. You will notice that the devices will hang and also. Right, so would not recommend that you run the lab in 8 processors. You can try to do the testing. but you might notice that the CPU utilization will be way too much high. So you can try to do the testing. Okay. So this is how you are going to do the labs. Again, any doubts if you have, you can let me know. There is one official certification guide. There is one official book for the Cisco SD-WAN. You can always refer to that official certification guide, official certification book for very detailed, discussion of the topic. Let me show you how it looks like. So again, this will be there on the portal itself. From the portal where you have joined the classes, this will be there on there. So this is how this official certification guide looks like, and you can practice, you can read this official certification guide for detailed discussion of the content. There are total 13 chapters here. We are going to cover all these chapters, just not in the exact same sequence. For example, when we will be talking about the deployment of the controller, we will talk about the deployment of the controller both on premises, on the cloud. When we talk about the migration, we'll talk about the migration. If it isn't, we're not going to talk about the migration in chapter 12. We'll talk about the migration just after the policies. So the content will be covered from here, just not in the exact same sequence. So you can just, whatever topic is covered in each class, you can always refer to the topics from here. You can see where that topic is, and then you can cover in detail from there. Right, so total 13 chapters are there. Here, like this chapter is, just what is SD-WAN, why we need SD-WAN, all those things. So the content will start from the chapter number 2, like components, operations, and also you can always keep an eye on this book. And this is what we are going to cover officially. Right, so 500 pages are there. You can always refer to these this document for detailed discussion. Apart from that, if you require any document, you can drop a message on the portal itself, and if any other document is required, that can be provided to you as well. Right, so this is like the entire content that we are going to cover, and this will include everything of your CCI content as well. If you talk about from the CCI content point of view, this topic will include whatever things we have covered today. From the content point of view, these things, all these things are there in the CCI exam as well. So for example, just to give you the quick idea, you go here, this is CCI enterprise infrastructure, SD-WAN, very limited content is there, but everything that we have discussed is covered in this one as well. Whatever they have mentioned here is covered in our SD-WAN classes as well. So you will not require any dedicated classes for this part if we are going for CCI enterprise infrastructure. Same thing, the previous classes that we had of the SD access, like this everything that they have mentioned here is what we have covered as part of our SDA classes. So again, you will not require any dedicated classes for the Cisco SDA. That is already done. Right, so SDA classes just before this, this batch, like SDA classes were going on, and we did cover everything from the SDA point of view in those classes. Right, so this is all about the content, how we are going to deliver it, how we are going to do the labs and everything. This is everything you need to know before we can begin the classes. Oh, of course, one more thing. This is this course that we are going to cover. This will need some basic understanding of certain things, such as it is expected that you know the routing. It is expected that you know about the protocols such as OSPF. It is expected that you know the protocols such as BGP, EIGRP, static routing, what is like switch, what is router, what is routing, what is switching. Like basic things at least, like, it is expected that you know. We are not going to, for example, quality of service. We will not talk about quality of service from A to Z. We'll talk about how to deploy the quality of service in the SD-WAN. We will not talk about OSPF from A to Z. We'll talk about how to deploy the OSPF in our SD-WAN. So the classes that we are going to cover will require some basic understanding of the routing protocols, switching concepts, basic things regarding such as what is like when you talk about security, for example, like you should know what is a firewall, what is a zone-based firewall, basic things regarding what is the URL, what does the URL filtering does. Our content says we have to implement these things in the SD-WAN solution. Our content is not going to focus specifically on things such as like you should know what is VRRP, you should know what are these things already. Like, you know, we are not going to, again, we are not going to talk about like OSPF, BGP, IGRP, or VRRP in very much detail. Same goes, for example, like here, if you want to deploy the controllers on the premises in an ESXi server, you should have the understanding of the ESXi server. No one is going to talk about the ESXi server. This is part of server deployment. So we are not going to talk about like what is ESXi, what is a Dell, what is a compute server, what is hypervisor, and all that. We are not going to talk about that. Right? Similar to that, other things as well. Like, you know, for example, we will talk about what is cloud on-ramp for SaaS, but we will not talk about like what is SaaS, what services AWS offers, what services like Azure offers, and all. We are not going to talk about that. Same goes for these things. You should at least have the basic understanding of these things that we are going to talk about. Our content says we need to focus on configuration part of all these things rather than talking about these things one by one in detail. Right? So basic routing and switching idea, you should have basic security concepts. You should have, for example, you should have basic understanding of the certificates. We will talk about like root certificate, device certificate, but in general, you should know what is a certificate and all. Right? So we'll focus on, from the lab point of view, we will focus on the things that they have asked us to focus on. But again, we will not talk about these things such as static routing, OSPF, BGP, EIGRP in detail. Right? So it's like once we start the configuration, I will configure OSPF in the router. I will configure EIGRP on the router. We'll not talk about what is EIGRP AS number and so. Like before every class, we will also, like, let's say, for example, I will tell you like tomorrow we are going to cover this topic. So you can revise those topics from somewhere, at least before the next class. Right? So again, basic idea you should have of the routing and switching before you can complete. Point I'm trying to make is that this is not a beginner's classes. Certain level of knowledge is required for these classes to complete. Right? So this is more like it should have medium to intermediate level of knowledge of your routing and switching concepts. Then it will be easy for you to understand all those things. It's not like you have to go in very detail of BGP. It's not like you have to go in very detail of OSPF, certificate installation and all that. No, just the basic idea. What is BGP? What is AS number? Like, you know, what is OSPF? What is process ID? What is router ID? Basic things. If you have even done the CCNA, that will be sufficient. But at least you should have the understanding of these things. Again, timing of the classes will be from 9 to 12 as discussed. We will take a short break, like we will have one session from 9 to 10:30, and then we will have a short break of 15 minutes. In 15 minutes, you can, you know, refresh up a little bit, and then we will start from 10:45 to 12. Like basically, we will have a short break of 15 minutes. You guys can refresh up a little bit in that 15 minutes, and then we will continue. Right, all the labs and everything that we have to do, we will do within this time frame itself. Right. So if you get, like, let's say, for example, if you are doing some lab, if you are getting stuck in some lab, like, you know, you can either drop a message, a mail, or there is also a WhatsApp group after a few a few weeks of the classes. Once it is final, like how many candidates are going to be there, then I will add you guys in that group so that you can have a general discussion in that group as well. Right. So I do have one WhatsApp group for the same, for the, like, it's not like you have to join it, but just in case if you are going to do the labs and all, it will be easy for you to, you know, get in touch with the other candidates and with me via that WhatsApp group. Right. So if you are concerned, like, you will people will get your number and all, so you can, it's not mandatory that you have to join that group, but in that case you will need to be dependent on the emails, like but in WhatsApp, like, it will be much more convenient if you have. Right. So this is how we are going to deliver the content. If you have any doubts, you let me know.
Yeah, I have one query.
Yeah, yeah.
It's regarding for the lab access. Can I get the URL?
That thing will be shared from the management itself. Like, you will get
Okay.
by the end of today's classes, you will get all the necessary documents and everything. The URL is simple, dc.mylabs.cloud. But this thing, your username, password, and everything will be shared from the management or your account handler. Like whoever is in, like whoever you are in contact with, they will share you the details.
Okay, got it. Got
By
it.
the end of
Thanks.
the classes today itself, you will get all the details.
Okay.
I would always advise you that if you guys have, if anyone has like some resources, some compute servers and all, try to build this lab at your home so that you do not have the dependency on this lab on the portal. You can try to build a lab on the ENG. You can watch the tutorials, and then this file can be shared to you so that you don't need to build all those things one by one. But how to add the images and all, you have to follow the URLs for the same. You can watch plenty of tutorials. There are a lot of tutorials on the YouTube for the same. Any question, anyone, let me know.
Sir, Viptela 18.4.4, will it do for the vManage?
The GUI of version 18 and version 20 is very different. I would personally, if you are just going for like from the concepts point of view, that will be okay, right? But the navigation bars and the UI is completely different nowadays in version 20. So I like, if you just want to do the practice and all, then it's okay. But from the real production point of view, I would suggest you to go for at least 20.6, 20.7.
How can we get it, sir?
The images and all, either you can download it from the portal, or I think like I will have to have a discussion with the management and they might be able to share the resources with you.
Sir, better you discuss with the management and try to share.
Yeah, because I personally am not allowed, and I also do not have the images of these. I got these things, pre-built on the servers. I'm also going to use the same lab as this one, right? So I will have to look like, okay, if these images can be shared in any way to you guys, then if it is possible, then definitely it can be.
Now, what is the, they have shared a lab with us, but what is the password? When I want
This
to
thing,
log in the
these
vManage.
things you had to discuss with them. Like I actually do not have any control or any knowledge about that part. So I think like they will have the idea and they will let you know regarding the same.
Okay.
Yeah. So let's talk about from the components point of view, like what is SD-WAN, what challenges the SD-WAN is going to solve, and how SD-WAN solution is going to solve those challenges. Basically, like what are the challenges in the in the traditional network, and how the SD-WAN is going to solve those challenges of the traditional network. So before SD-WAN came into the market, we had this thing like we still had the WAN, we still had the wide area network. WAN refers to a concept where we want to connect our campus area network, our data center, our headquarter, maybe, all the different branch 1, branch 2, branch 3. WAN basically refers to a concept of interconnecting like all these geolocations all together with the help of some sort of transport. Transport could be like a public transport, such as like internet transport. Transport could be a private transport, such as like MPLS, multi-protocol label switching transport. So we used to have like different locations, such as data center. We have, let's say, for example, multiple data center. We have headquarters. We have, let's say, for example, branches, branch 1, branch 2. We have some small sites and all. We have some partner sites and all. So we have different like devices in different like locations, and we want to connect all these devices all together. So we used to use this concept called WAN. WAN stands for wide area network. So what we used to do, actually, we used to connect a router at our data center. For example, we used to connect a router at our branch headquarter. And we can use any transport such as internet transport. We can use transport such as other WAN transport, such as, for example, MPLS, such as, for example, Metro Ethernet. We can use different types of transport to interconnect all these devices together. Right, so we can use MPLS transport to interconnect all these devices together. We can use like other WAN transport such as Metro Ethernet MPLS to connect all them together. In earlier in the traditional WAN, what we used to have the routers like connected at the edge of our network. We used to call them CE, customer edge routers, and these customer edge routers are used to connect to the WAN transport such as internet to the WAN. And by connecting these routers to the internet transport and the WAN transport, we can connect this router with the other location devices as well, so that the devices can communicate to each other over this transport, over this public or private transport. And there are like a lot of challenges in the traditional wide area network. Like, for example, one of the major challenge that we have in the traditional wide area network is the challenge of managing all these managed routers. One of the biggest challenges that we have in the traditional network is to manage like all these managed devices that we have in the network. Let's say, for example, let's talk about like our company. Let's say they have like 4 data centers. They have like approximately 8 headquarters, and they have like, let's say, for example, 500 branches all around the world. And in every data center, in every headquarter, in every branch, let us assume that at least 2 devices are there at the WAN edge. And let's assume that at least 2 devices are there to provide the connectivity from the data center to the other devices, from the headquarter to the other devices, from the branches to the other devices. So that gives us like approximately like a lot of devices, 500 branches, 2 devices in every branch. So it is going to be 1000 device, 8 headquarter, and in every headquarter there are at least 2 devices. So 16, so 8, like approximately like 1000, 1100 approximately devices are there. And these devices are the WAN devices. And what we need to do, we need to configure all these WAN devices all by ourselves. We need to troubleshoot, we need to manage all these devices one by one by ourselves. We typically are going to have some engineer at data center. We typically will have some engineer at the headquarters. We typically will have some engineer at the branch network, so that the management can be done locally from that particular device. So one of the biggest challenge, as said, one of the biggest challenge in a traditional wide area network, traditional WAN, is the management of all these WAN devices. No doubt, we have a lot of management tools. We have a lot of like monitoring tools, SNMP monitoring tools, and all those things we have. If you want to configure devices on n number of devices, we might have some configuration tools as well. We might do some sort of scripting. We can run some Python scripts and all, so that the configuration can be pushed on all those 1000 devices at once. That can be done. We have like a lot of solutions in a traditional WAN network as well. But having like different solutions, like we have one dedicated solution for the management, one dedicated solution for the configuration, one dedicated solution for the troubleshooting. We have different tools, and a candidate need to be aware of all those tools if they want to do the management, if they want to do the configuration, if they want to do the troubleshooting and all. So we do have tools in the traditional WAN as well, but like the candidate must be aware of those tools so that they can do the troubleshooting configurations with the help of those tools on multiple devices. For example, a candidate must know how to run those Python scripts. A candidate must know how to create, how to write down a Python script, so that multiple devices can be configured in just one go. And not as everyone knows that not everyone is very good with the scripting and all. So we do have a solution, but they do not work like very well. They do not used to work like very well in a traditional WAN environment. And why we have the complexity, why we have the challenge, like when we need to configure or manage all these devices. Why do we have the challenges in the traditional WAN? Because all these routers that we use to connect in our traditional WAN, all these WAN edge routers that we use to connect in the traditional WAN, all these traditional routers, if I say, all these traditional routers, they have their own management plane, they have their own control plane, and they have their own data plane. From the architectural point of view, function of a router, a functionality of a router can be divided into three architectural planes. We can say that there are three components of this router, and these three components of the router handle three different things of the device. Like, for example, the management plane of the router handles how the device is going to be managed. How are we going to configure this device? Are we going to configure this device via command line interface, or are we going to configure this device via graphical user interface? Or are we going to use some sort of SNMP tool to push some configurations onto these devices? Or are we going to use some API calls to again push some configurations onto these devices? Management plane of the device, not only the router, on the switches, on the other devices as well. The management plane of the device, management plane of the router handles the device management. Like how the device is being managed, how the device has been accessed by the administrator, and how the device is being managed. How the device is being managed is handled by the management plane of the device. Management plane of the device handles the device management. And since every device has its own management plane, if you have like 1000 devices, you cannot just take the access of one device and configure all the devices from there. You cannot do that, because since we have like 1000 devices and every device has its own management plane, every device needs to be accessed. You need to access all these devices one by one. And once you access these devices one by one, then only you will be able to do the configuration on all these devices. Why the device management of all these like 1000 devices is tough in the traditional WAN? Because every device has its own set of management plane. And because of that, like we need to configure, we need to first of all take the access of that device one by one, and then we need to do the configurations on that device one by one as well. Okay. Second, from the architectural point of view, the second component that the device has is something called the control plane. What is this control plane? Control plane is responsible to build variety of tables onto the device. Tables such as, for example, routing tables. Tables such as, for example, naval table. Tables such as, for example, database table, routing table, MAC table, MAC address table, and all that in case of switches and all. Control plane means the CPU. Control plane tasks means the CPU intensive task. Everything on this device, everything that is generated from the device is what we say that it is generated at the control plane of the device, or we can say that it is generated by the CPU of that particular device. Control plane, the purpose of the control plane is to do is to create variety of tables such as naval table, database table, routing table, and all. And based on these tables, the data plane is going to decide how to forward the data. Control plane controls the data plane. Control plane tells the data plane that, okay, use this entry in the routing table to do the data forwarding. Control plane is the one responsible to actually instruct the data plane on how the traffic needs to be forwarded. If the packet has arrived onto this interface and the packet has the destination IP of 10.1.1.9, the packet needs to exit out of the interface at 0/2. That is told, that information is given to the data plane by the control plane. Control plane controls the data plane. Control plane is the one that tells the data plane that the packet needs to be forwarded out of this particular interface in this manner. Control plane tasks, control plane operations are CPU operations. Control plane is basically responsible to control. Control plane is responsible to control like how the data forwarding is going to happen. Control plane is going to build variety of tables. Based on those tables, the data plane is going to decide like how to forward the data. And the point is, every device has its own set of control plane, and every device has its own set of data plane as well. That means you cannot just run OSPF here and it will configure OSPF on all the routers. It just cannot happen. If you want to configure, if you want these two routers should exchange the route, You need to configure OSPF routing protocol here. You need to configure OSPF routing protocol here. Then these two devices will exchange variety of messages. They will form the OSPF neighborship. They will exchange their database. They will build their routing table. And based on the routing table, the data plane will decide how to forward the data. Basically, since every device has its own set of control plane, we need to configure the things on multiple devices from the control plane point of view as well. Such as, for example, if you want to configure the routing between the devices, you need to configure it on both the devices here as well, like on this device as well as on this device. Same, every device has the data plane. Every device has its own data plane as well, which means like the entries in the routing table that are here can be used only by this router to forward the data. This router that we have cannot use the entries maintained in the routing table of customer edge router 1 to forward the data. If this router wants to forward the data, the routing entries should be available on this particular router. That means this router will need to maintain some sort of like table to decide like how to forward the data from one point to other point. Every device has its own control plane, management plane, and data plane. Every device has its own set of control plane, management plane, and data plane. We say distributed. We have a distributed control plane, management plane, and data plane. Like the device has its own set of control plane, management plane, and data plane. That is why if you want to manage 1,000 devices, you need to manage those 1,000 devices one by one. Why? Because every device has its own set of management plane. Oh, you need to configure the routing protocol. You need to configure the routing protocol. You need to configure the routing protocol on all those 1,000 devices, because every device will have its own set of control plane. You want these 1,000 devices to properly forward the data from one point to other point. All these devices, all these 1,000 devices, they will maintain the table such as routing table of its own, and they will use their own routing table to decide how to forward the data. Distributed, some sort of distributed architecture is there. We have distributed control plane, data plane, and management plane in the traditional WAN, and that is why we need to do the device management of all the devices one by one. That is why we need to configure the protocols on all the devices one by one. That is why we need to make sure that every router has, for example, maintained the routing table so that they can decide how to forward the data. So traditional WAN has a distributed control plane, data plane, and management plane. If we have 1,000 traditional routers, we will have 1,000 control plane, data plane, and management plane. You will need to take the access of all those 1,000 devices one by one so that you can do some configuration tasks. Once you do the configuration task, all these devices will build some sort of tables. And based on that table, the device will start forwarding the data. Okay. So device management becomes a very challenging task in a traditional way. If we have like n number of branches, n number of headquarters, n number of data center, and in all those n number of locations, we have n number of devices, it will be like too much configurations that the administrator need to do in order to make all these things functional, in order to make like the reachability between the devices, the communication between the devices. A lot of configuration will be required to be done by the administrator. Okay. Second thing is that nowadays, the way we are going to access the network is also changing. The enterprise network has a greater demand for mobile and IoT devices traffic nowadays. Nowadays, we have things such as work from home has allowed us that we can just take our laptop at our home and we can do the work from there. We can take the access of our company resources from our mobile device such as laptop. Mobile doesn't mean mobile. Mobile means like mobile device. Mobile could be your mobile phone. It could be like laptop, desktop, like anything that is mobile, that is not fixed. So enterprise network has greater demand for mobile like devices nowadays. Like we can have a user typically going to have a laptop, and a user is typically going to have at least one mobile phone. A user can also have at least, like, let's say, one tablet, and they can use the company resources from the laptop, mobile phone, from the tablet, and all those as well. So enterprise network has a greater demand for the mobile devices, and IoT, Internet of Things, such as cameras, such as phones, like different IoT devices, sensors, and all, it has also increased in the network nowadays as well. Internet of Things device, IoT devices such as smart home appliances, such as CCTV camera, coffee machine, different appliances that we have. Nowadays, we have a lot of IoT devices as well, and those devices are also sending certain type of traffic that we need to handle. In earlier days, we do not have things such as IoT that much popular in the network, so we had very limited amount of traffic for the IoT devices. But nowadays, IoT devices are also sending some type of traffic that the devices need to handle. Companies are nowadays not even deploying the applications on their machine. Companies are nowadays following the concept of SaaS, software as a service. What is this SaaS? What is this software as a service? What is this SaaS? What is this software as a service? SaaS basically allows us, SaaS, like software as a service. SaaS allows the service, like SaaS, software as a service, allows us to deploy the applications on the cloud. Like, do not deploy the application, do not deploy the software onto local machine. SaaS, software as a service, allows us to deploy the applications on the cloud. A very good example of the SaaS application would be Office 365, such as Dropbox, such as your Gmails and all. Right. So, like, nowadays we do have like software as a service, like SaaS applications. We have the applications deployed onto the cloud. Right. So, for example, Office 365, we do not need to, for example, nowadays install the Microsoft Office on all these devices. The users can access the services of the Office from the cloud itself as well. Companies can deploy their infrastructure on the cloud nowadays as well. Like, instead of having a physical infrastructure, they can deploy a branch, a data center on the cloud as well. So infrastructure as a service, where the companies choose to deploy certain infrastructure on the cloud as well. So, and apart from that, some generic cloud adoption as well. Like, we can deploy nowadays firewalls on the cloud. We can deploy a lot of appliances onto the cloud. You can just go, for example, just to get the idea, you can just visit the AWS marketplace. AWS is one of the cloud service provider. You can just search AWS marketplace, and you just visit this AWS marketplace, and here you can search here Cisco, and you will see the list of services that can be offered from Cisco onto the cloud itself. Right? You can select the vendor from here accordingly. The point is that nowadays we have a lot of services deployed on the cloud nowadays. Like, applications are getting deployed onto the cloud, like Office 365, Dropbox, CRM applications are getting deployed onto the cloud nowadays as well, so that the users can access the things from anywhere. Not like they have to necessarily come to the office to do their task. The application is deployed on the cloud. If they want to actually, access the services, they can just access it directly from the cloud. If anyone is facing the audio issue, you can rejoin once. It's more like a browser issue. In most of the conditions, most of the situations, it's a browser issue. So if you guys face any voice related issue, you can rejoin once, it will fix, or just refresh the browser once, it will fix. Right. So see, for example, I just searched Cisco here, and we have a lot of things that are offered. Like, for example, nowadays we can run a router on the cloud as well. The VH, same VH that we were talking about. Like, you can just click on that. We can run nowadays a router on the cloud on a subscription basis, like $0.105 per hour. Subscription basis, we can run this router onto the cloud. The point is that nowadays applications, softwares, like services are moving to the cloud. A lot of things are moving to the cloud. So modern day WAN devices not only need to handle the enterprise network traffic, they also need to handle the traffic that is going towards the cloud. For example, here is a user. The user is trying to access the Office 365 application. And the user is facing very latency. It is facing like the challenges. The Office 365 is not loading properly. It is very slow. Basically, the user experience of the Office 365 application that is hosted on the cloud is very bad. Because your traditional WAN router, what it has done, this traditional WAN router, let's say, we have not done any optimization on this traditional WAN router. So this traditional WAN router has received that Office 365 traffic, and it has sent that Office 365 traffic all the way to the data center. From the data center, the traffic got inspected via a variety of firewalls, and then it got sent to the internet. So of course, the latency will be there. What should be done? That from this router, if the traffic belongs to Office 365, the traffic should directly go to the internet without going to the data center being inspected via the firewalls and all. Why would I need to do the inspection of this traffic from the firewall? Why will I need to send all this traffic to the data center? This is just like an Office 365 traffic that the user is trying to access, like the Dropbox traffic and also.
Sir, normally outbound traffic is not checked by the firewall, isn't it?
Yeah, that could be. That is basically the rules that you have applied on the firewall. We are just saying that okay, the routers on the router, since the router cannot differentiate that okay, this is an Office 365 traffic that need to exit locally. The traffic will be sent to the data center, and from the data center, the traffic will be checked via a variety of appliances, and then it will be allowed to go towards the internet. Like we might have added the exception for that traffic on the firewall and all. We can do that. But the point is that the latency that the user is experiencing is because the traffic that arrived on this traditional WAN router was sent to the data center, because this traditional router could not differentiate between a regular traffic and the traffic that is being sent to the cloud for application that is hosted on the cloud. So same goes for the same thing for the traffic of the infrastructure that is hosted on the cloud. Maybe what you have done, you have configured a few branches on the cloud. You have run some appliances onto the cloud, and now you want to extend your existing infrastructure. You want to connect your existing infrastructure to those appliances that you have deployed onto the cloud. Maybe we can deliver like nowadays. We can we can run the devices such as firewall onto the cloud. So maybe what you want, that the traffic that has to be sent from the branch 1 to branch 2 must first be sent to the firewall for the inspection, and then from there it will be go to the other branches and other cloud options as well. The whole point is that the traditional devices, the traditional routers that we have, we should configure something on those traditional routers so that they can identify they can do some sort of differentiation between the traffic that is for the traditional network and that is for things such as like SaaS, things such as for infrastructure as service and other, let's say, for example, cloud services. Point is that the traditional WAN needs to be ready to handle the traffic that is being sent for the SaaS and infrastructure as a service and other cloud resources. Maybe some IoT device has sent the traffic. Maybe some IoT sensor, some IoT device has sent the traffic. How this traditional WAN is going to deal with that traffic? How this traditional WAN router is going to deal with the traffic? It is how this traditional WAN router is going to handle the traffic that is for the SaaS application, that is for the infrastructure as service application, that is for the IoT device traffic and all. And what about the security? In addition, security requirements are increasing and applications are requiring prioritization and optimization. Okay, so what we are saying, that we have different types of application now that they are deployed onto the cloud, and how the traditional WAN is going to deal with those different types of traffic that it has received. The traditional WAN router has received the traffic that is for the traditional network. The traditional WAN router has received the traffic for SaaS application, for infrastructure as service, or the other like IoT traffic, the cloud, other traffic for other cloud delivered application or infrastructure. So the question is that how your traditional WAN router is going to deal with all those challenges that it will face because of the SaaS application, infrastructure as service application, IoT devices, and all. So different challenges you will face in case of traditional network. Also, the security requirement. We have a small branch. Here we have a small branch. Here we have a few users, and on this branch, what we have done, we have used this thing called DIA. DIA stands for Direct Internet Access. What we have done is that on this branch, for this users in this branch can actually access the internet services directly without going to the data center and all that. We have used this concept called DIA, Direct Internet Access, where the users on this particular location are going to access the internet services. They will be able to access the internet services directly. When we configure things such as DIA, when we allow this router to send the traffic directly to the internet, a lot of challenges regarding the security also are now there. A lot of now security related requirements can also be there. Right, so security related requirements can also be there in general cases, in other cases as well. We might want to add, I want that the user should not send any sensitive data to like the internet. I want to inspect the things. I want to inspect, like, I want to inspect all the traffic that is being sent from one device to other device. I want to do some sort of inspection for the same. So I want to also enforce the security in our enterprise network. I do not just want to send the traffic right to the cloud, right to the internet. I also want to enforce the security in our infrastructure network. Is the audio issue to anyone else? Like, can you guys hear me properly? Is the audio still giving you any problem? Rejoin once. If anyone is facing the audio issue, you can rejoin once. It's mostly like the browser issue. Rejoin once. Okay. So we also want to enforce some security. We want, like, the traffic that is going from branch number 1 to branch number 2. It must first be inspected via some sort of firewall, and then it must be sent from one branch to other branch. Maybe I want to inspect the traffic that is being sent from this particular user, the traffic that is going towards the internet. So we might also want to add, some sort of security related requirements in the network. So security requirements are increasing. Applications are requiring, for example, our SaaS applications or our audio video applications needs to be prioritized and optimized as compared to our regular application traffic. I want that if the user is accessing the Office 365, or if the user is accessing some CRM application, maybe the user experience should be like proper. So we also want to prioritize the traffic of the Office 365 CRM application and some other application over the regular traffic. So new requirements are coming in a modern day like network, like common business and IT trends in nowadays. Like we have different types of IoT devices, SaaS applications, infrastructure service application, other cloud adoption. So our WAN devices, our WANS devices should be ready to handle all these types of traffic. We also need to enforce proper security in our branches. We also need to prioritize the traffic of certain applications. We also need to optimize the traffic for certain applications as well. WAN is evolving to manage changing application landscape. There are more users nowadays. Users can access the applications from the mobile devices. The users can access the application via laptop, desktop, other like devices such as tabs, tablets, and also the user requirement has grown a lot. Applications are being sent to the cloud a lot, like the applications are being deployed onto the cloud rather than being deployed on each and every machine. I do not need to deploy the I do not need to configure, I do not need to install Microsoft Office on all the devices. For example, I can just purchase the subscription of Office 365 for our employees, and I can give everyone the access to that Microsoft Office on cloud basis. So we are also going for like software as a service thing. We are going for infrastructure as a service thing. Branches are getting the DIA. We can access our network from anywhere, anytime. So like WAN, the traditional wide area network has to deal with the challenges that are listed here. The traditional wide area network has to deal with like user requirements. The traditional wide area network needs to handle the application traffic that is hosted on the cloud. SaaS application, infrastructure service, IoT, DIA, like different challenges are there in a modern day network when it comes to like a wide area network. So we have like guest users. For the guest users, I want a DIA. I want direct internet access for the guest user. I do not want that for my guest user. The traffic is being sent all the way to the data center and then being inspected via firewall and then being sent towards the internet. The guest user is just browsing some Facebook application. I do not want to send the traffic all the way to the data center for the inspection purpose. So for the guest user, let's say, for example, I want DIA, but for rest of the traffic, that goes from branch to headquarter and all, the traffic must be properly inspected via some firewall and then be sent from the data center to the headquarter to the data center, something like that. Applications are moving to the cloud, internet as is moving to the branches, like DIA concept is there nowadays onto the branches, applications are moving to the cloud. And also, like not one cloud, we nowadays have multiple cloud providers, like we have, for example, AWS, we have Google Cloud, we have, for example, Azure, we have like other clouds providers such as Alibaba and all that. So we have different cloud service provider nowadays. A company might get certain services good in one provider and company might get certain services good on other cloud providers. So they opt for like more than one cloud service providers in their infrastructure. Like maybe, for example, Office 365, they got from the Microsoft, and for the other some generic, they have hosted some infrastructure on AWS cloud, and they have hosted one of the router in the Google cloud. So companies can not only go for one cloud, but they can go for multiple clouds as well. Some services are better in one cloud, so they have opted for those services from that cloud, and some services are better in some other cloud, so they have opted for those services from that cloud. So multi-cloud nowadays. Multi-cloud basically means that the companies, they are going for like multiple cloud solutions rather than relying on the single cloud solution. So these are the common business and IT trends that is going on in a current in a modern network, and this adds this all things that is listed here. This is going to add a lot of complexity in the network as well. This is going to add the complexity in the network. The challenges that are there in the traditional WAN is that it is complex to operate. First of all, complex to operate basically means same thing. We have like 1,000 number of devices, and all those 1,000 number of devices needs to be managed like one by one. So an administrator needs to take the access of those 1,000 devices one by one, and then they will be able to do the management and all. So the operational expenses are going to be much more higher in a traditional WAN environment. In the traditional WAN environment, the operational expenses is going to be way too much. It is complex to operate. The operational expenses are going to be way too much in a traditional WAN. It is difficult to secure. What does it mean? It means that, let's say, for example, we have 1,000 branches and we want to enforce the security on the 1,000 branches. We need to add some sort of security appliances on all those 1,000 branches. Like maybe we need to add some UTM devices, we need to add some firewalls, some IPS IDs. We need to add some security appliances on those 1,000 branches so that we can enforce some level of security. We can add some level of security for those branches. And you are going to deploy a security appliance on 1,000 devices, on 1,000 branches, then again, you need to manage those security appliances again one by one as well. So your traditional WAN is going to be difficult to so there are different ways to do to enforce the security in the network. Rather than like deploying a firewall on all these branches, you just deploy a firewall on the data center, send all the traffic to the data center, and from data center send the traffic to the other branch. That can also be a solution. But the problem in this situation is going to be latency. Like the traffic that needs to be sent from this branch to this branch first needs to be sent to the data center for the inspection. Once the inspection is done, then only the traffic is allowed to go to the branch. So it will add some latency in the traffic. So either you can enforce the security by adding the devices everywhere, or like it is going to reduce the latency, but it is going to increase if we have like 1,000 branches. and in every branch you have added, let's say, just one firewall, then you need to manage those 1000 firewalls again one by one as well. So if you add security everywhere, then it will be complex to manage. And if you add the security just, for example, in the data center, then the latency problem will arise. So the traditional WAN is actually difficult. The traditional WAN is difficult to secure. We can enforce the security. It's not like we cannot do it. We can do it. We can secure the traditional WAN network, but it is going to be like difficult to secure the traditional WAN network. User experience might not be very good for the applications that is hosted on the cloud, infrastructure that is hosted on the cloud. If you enforce the security, for example, everywhere, too much, it will be like too much administrative overhead to manage all these security appliances in every branch. And if you have enforced the security via data center, the user experience will be like not so good, like poor user experience, because all the traffic is going towards that data center, from the data center to the firewall, then from there to the other branch, and also this is going to result in poor user experience. So the challenges in the traditional WAN network, we have the challenges regarding security. We have challenges regarding the application awareness. Like we can have different types of applications, such as, for example, we can have SNMP monitoring application. We can have some tools to do the configuration on those 1000 number of devices. We can have some tools to perform the troubleshooting. So a person must need to be aware of all those applications that they can use, all those tools that they can use to troubleshoot the network. And your traditional WAN router is not aware of the application. If the traditional WAN router is not aware of different types of application, it cannot decide like which application to prioritize over which application. Limited app awareness, like your traditional WAN router is not aware of like all the applications that is currently available in the market. We do have things such as in the traditional WAN, we do have things such as NBAR, network-based application recognition, where the traffic can be recognized by the protocol name and all. But NBAR needs to be configured on the device by yourself, like. So, and the support in NBAR is for very limited applications are there. Like we have limited the devices are the managed routers are aware about the limited apps applications, limited application traffic, so they can do like limited level of optimization for the users. Your traditional WAN is not ready to handle the applications that are delivered on the cloud. Your traditional WAN cannot handle like the traffic that is being sent to the cloud. No cloud app readiness. If the application you have deployed onto the cloud, your traditional WAN router might not be able to handle the traffic for that cloud delivered application properly. There's no such optimization that we have done on this traditional WAN router for that cloud delivered application. The operational expenses of managing the traditional WAN network is going to be way too high. As per some research, like companies, they spend like 50 to 60% of their expenses on the operational expenses. Like in a typical environment, you might face different challenges, different issues, and that will result in like high operational expenses, high cost to manage the traditional WAN network. Complex operations, like we need to handle all these devices one by one, so it is complex to handle. Bandwidth insufficient. Nowadays, the applications are not being delivered only on a desktop, they are also being delivered on the mobile devices. The application that is being delivered, it has very rich dynamic content which consumes a lot of bandwidth, and also the bandwidth requirement for modern day applications and resources is also comparatively high. So you might face like insufficient bandwidth issue for the certain applications as well. In earlier days, the applications that we used to have, they used to have like a fixed type of content, like, but in nowadays, like we have different type of like applications that have rich dynamic content. So that will be like challenging. Okay. So these are like some challenges. These are like traditional WAN imposes like the challenges when we need to operate this. So traditional WAN is complex to operate, difficult to secure, and the user experience in the traditional WAN is not going to be very good. The challenges that you will face in the traditional WAN is challenges regarding the security. Your traditional WAN is not aware of all the applications. The traditional WAN is not ready to handle the traffic of the applications that is hosted on the cloud. The maintenance cost of the traditional network is comparatively high. The management of all the WAN devices. I'm just talking about the WAN devices. The management cost, the operational, the configurations, operations of the traditional WAN is going to be comparatively higher. Since we have different types of applications, the applications can have rich dynamic content. The bandwidth requirement for modern day applications is also high, so you might face like insufficient bandwidth for different types of application in your network. An application might consume a lot of bandwidth. Because of that, the other applications might suffer. The other applications might not be able to get the proper outcome. The user experience for the other application might not be good enough. So some general challenges are there in a traditional wide area.
If we increase the bandwidth, then problem will be solved.
Yes, but not necessarily. Like increasing the bandwidth could be one of the solution. Increasing the bandwidth, it could be one of the solution, but not always, because if you increase the bandwidth, like you need to pay again some extra money for for that additional bandwidth. Better to use some optimization technique, better to use some maybe configuration commands, some policies, so to limit the application traffic for the same. But yeah, if you purchase more bandwidth, that will also solve the problem, but it will add some operational expenses as well. Same thing goes for example, like security. You can add a very good security. You can have a very good security in your network. You can have a very good security in your network. You can have a very good security in the network by adding a firewall on all the branches. But again, if you add a firewall on all the branches, first of all, the cost is going to increase. Second, like you have to manage all those firewalls again one by one. So again, complexity you are going to increase. Right? So these are some general challenges of the WAN network. And it's not only about the WAN, we also have similar type of challenges in our LAN network. Not only WAN, we also have these challenges in a local area network, in the LAN network as well. Typically in the LAN network, we have different types of switches. We have typically, let's say, for example, this type of diagram in a traditional local area network environment, the traditional LAN environment. So what about the management of all these LAN devices? Like we are just talking about from the WAN point of view now at the moment. Like these WAN-edge routers, we are talking about the challenges that we have in a WAN network. We also have the challenges in the LAN network. We have like we have, let's say, for example, 1000 branches. And in those 1000 branches, we have, let's say, only 5 switches per branch, let's say. And on average, let's say we have 5 switches in every branch. We also have some wireless LAN controller. We also have some access points. We have like different devices in all those branches. How are you going to manage all these 5,000 number of switches from one centralized point? How are you going to manage all these maybe 2,000 number of access points from one point? How are you going to add the policies for the wireless network from one? So the challenges are not only there for the WAN, the challenges are also there in a LAN infrastructure of a company as well. However, as a part of this content, we are not going to talk about the challenges in a LAN. We are just focusing on the challenges that we have in the WAN. Let's say you need to set up 20 more. Let's say you need to set up 20 more, let's say, for example, branches. And in every branch, you have to add at least 2 WAN-edge router. You will need to, first of all, deploy those WAN-edge routers onto those branches. then you will need to do the configurations on all those WAN routers all by yourself. Then you will need to make configurations such as IP address, configurations such as DNS, configurations such as maybe DM VPN, configurations such as like MPLS, like a lot of configurations you might do on all those WAN devices, and then only your network will be up and ready. It will also consume time. If you need to add on, like if you need to set up like 20, like let's say 20 more branches, the overall time taken to deploy these 20 new branches is going to be very high as well. These are some challenges, not all the challenges. These are some challenges that we face in a traditional wide area network. Other challenges will come in the form of like the time that you will take to resolve a problem once it is reported, time taken to deploy, for example, a device into a branch and make it up and running. Like a lot of other challenges will be there as well, but these are some general challenges that we are like too much concerned with in a traditional WAN requirement, in a traditional WAN network. So modern day WAN is not just only about like modern day WAN is not only about connecting our branch headquarter data center all together. It's not only about providing the internet connectivity on all these like branch headquarter and data center. It is also about dealing with the challenges that we have in a modern day network. So we have the challenges in both WAN side and we have the challenges in the LAN side. And let's not even talk about the challenges that you will face in a data center network. Let's not even talk about the challenges that you are going to face in a data center network. A data center network that is built around an application, that data center network that is built around an application that it is going to serve. Maybe storage, maybe for example, a Facebook data center where the Facebook user accounts and all that information is going to be stored. Maybe a Google data center where all the emails, all the things are going to be stored. Let's not even talk about the challenges that you have in managing the data center devices or data center network itself from one centralized point. So we had the challenges in the DC, we had the challenges in the LAN, we had the challenges in the WAN. So what they did actually to solve these challenges that we have in a data center network, in a LAN network, in a WAN network, what they did actually, they tried actually to introduce some software defined approach. They said that users are not going to, like administrators, they are not going to solve these problems all by themselves. Let's do one thing, let's build some softwares, and that software, the machine, the software is going to solve these challenges that we are actually facing. So they introduced this thing called software-defined networking, and this software-defined networking concept was very, very widely deployed in a data center network earlier. Data center networks, they have been using the concept of software-defined networking for a very long time. In the data center environment, they used to use things such as like they built the data center network based on the concepts of ACI and EPIC. EPIC, Application Policy Infrastructure Controller. This is the piece of software that is responsible to manage the entire data center network from one single point. They create this thing called ACI based data center. They create this ACI data center, and this ACI data center is managed by this controller called EPIC, Application Policy Infrastructure Controller, which is again just a piece of software. It is just a software that is responsible to manage the entire data center network and the policies and everything from one point. EPIC, ACI, EPIC was like, very popular solution. It is still a very popular solution in a data center network when it comes to software-defined networking. So software-defined approach to manage the data center network is basically SDN for DC. Software-defined approach to manage the data center network is what we refer to as the software-defined networking for the data center network, and it is done with the help of ACI, application-centric infrastructure. The data center network is built around the application that it serves, hence the name application-centric. The data center infrastructure is application-centric. So application-centric infrastructure, the DC, and EPIC is the controller that is used to manage that data center network. EPIC is the SDN solution. EPIC, Application Policy Infrastructure Controller, is the SDN solution for the data center network. And they've been using this EPIC for quite a long time, like very long time they have been using this EPIC. It was so popular in data center network. It was like so popular for the data center network that they built an enterprise version of the same as well. They built an enterprise version of this EPIC controller, Application Policy Infrastructure Controller, EM. They built an enterprise module of this EPIC controller as well. Application Policy Infrastructure Controller, EM. EM stands for EPIC enterprise module. They thought that since EPIC, Application Policy Infrastructure Controller, it is a very good controller to manage all the data center infrastructure in a very, very precise way. Why don't we build the same? Why don't we build the same type of network for our enterprise campus network as well? So they built this EPIC EM. EPIC and EPIC EM are two different things. EPIC is for data center and EPIC EM is for enterprise network. The EPIC EM is what used to manage the campus local area network. EPIC EM was the controller for managing the enterprise local area network. EPIC EM was the SDN solution offered by Cisco. EPIC EM was the SDN solution offered by Cisco to manage the campus local area network. All the switches that we have can be managed via this EPIC EM controller. Unfortunately, it could not get very popular. Like people were, they were already using some other, tools such as prime infrastructure, PIE, and other things. So this could not gain a lot of popularity. This could not gain a lot of popularity in the enterprise network. EPIC EM, EPIC enterprise module, could not gain like a lot of popularity for the enterprise network. Enterprise network, they used to use things such as prime infrastructure. It was again a SDN solution to manage the LAN network. So prime infrastructure and other solutions were there as well. Unfortunately, EPIC EM could not gain that much popularity. Okay. Then came in the market this. So to deal with the challenges that we face in a local area network, they had the controller solution EPIC EM. EPIC EM was the SDN solution to manage the campus local area network. Other things were there as well, such as prime infrastructure and all. But EPIC EM, like what Cisco offered to manage the campus local area network from one centralized point. And then came in the market an age and era of software-defined wide area network. Same thing, software-defined approach to manage the WAN edge devices. Like all the WAN edge routers that we have, we are going to use some piece of software to manage all those devices from one centralized point. Software-defined approach to manage the WAN edge devices is what we refer to as the SD-WAN. SD-WAN is software-defined approach to manage the WAN edge devices. We have 1,000 branches, and in all those 1,000 branches, at least 2 routers are connected at the edge. That means we have 2,000 routers connected in total. All these 2,000 routers can be managed from one centralized point. All these 2,000 routers can be managed from one centralized point. Software-defined approach to manage all the WAN edge routers from one point is what we refer to as the SD-WAN, software-defined wide area network. Now, Cisco offered a technology before this SD-WAN became very popular. Cisco used to offer a technology called I-WAN, intelligent WAN. When they were facing all these challenges in the traditional WAN environment, they offered this solution called I-WAN. I-WAN stands for intelligent WAN. Alongside this I-WAN, other vendors were there as well who were offering the SD-WAN solutions. One of the vendor that was offering the software-defined wide area network solution was Viptela. Viptela was one of the vendor that was providing the SD-WAN solution. It was like quite popular when they used to have their own operating system. They used to have their own set of controllers from where we can manage all these things in a centralized point and all. So it was quite popular, like Viptela SD-WAN. People did not know about it. Like people were still only the people who were in the production environment, who were seeing the software-defined networking in their deployment, were aware about that. But this SD-WAN solution is there for past 8 to 10 years in the market. Like it is there like from past 8 to 10 years in the market. It is very recently that it has gained the popularity. In approximately 18-19, it gained very popularity. Like very popular. This software-defined solution has become. And I think around in the same time period, Cisco acquired Viptela around 16-17. They acquired Cisco acquired Viptela. So now it became like Cisco SD-WAN Viptela, based on Viptela, or just simply nowadays referred to as the Cisco SD-WAN. So Cisco offers a solution to manage all the WAN edge devices from one centralized point. And the solution that they offer to manage all the WAN edge devices from one centralized point is called SD-WAN. So SD-WAN, software-defined wide area network, SD-WAN is an approach to manage all the WAN edge devices from one centralized point. Cisco offers two SD-WAN solution. One is like Viptela based for large to medium scale network. And for a small scale network, they also offer Meraki based SD-WAN, where you just purchase Meraki devices or from their portal, from the Cisco, you purchase the Meraki devices and you get a cloud dashboard. From there, you can manage all these things. You don't need to deploy any controller or anything for the same. You just purchase the device, add it on your network, and provide it internet connectivity. It will be registered on the Meraki portal on the cloud, and then you can manage the things from there itself. Like for the small businesses, it is a very good solution. Viptela based SD-WAN is what we are going to cover. We are going to talk about Cisco SD-WAN based on Viptela. Now, when SD-WAN became very popular, when like in 18, 19, 20, like when SD-WAN became very popular, they relaunched. When SD-WAN became very popular, they relaunched Epic EM. They actually relaunched their old software-defined networking solution for a campus local area network, software-defined SDN solution for a LAN network. They relaunched this Epic EM, but not with the same name. They launched it with the name of DNA Center. So what they did actually, they repurposed the Epic EM controller that they had. They added some monitoring. They added some assurance feature in that Epic EM module, Epic EM controller they used to have. They added some assurance, just monitoring functions, a lot of monitoring functions they added, and they launched a dedicated controller, a dedicated hardware with the name of Cisco DNA Center, Digital Network Architecture DNA Center. So DNA Center nowadays, DNA Center is the software-defined solution to manage the campus local area network, which is also what we refer to as software-defined access, or SDA. So overall, Cisco offers three solutions when it comes to software-defined networking. Cisco offers
excuse me, sir. Can you please just tell about the DNA? Cisco again launched the DNA, and then what happened?
And the point is that they earlier had a product called Epic EM, right, which was their SDN solution for the enterprise network. However, it did not gain a lot of popularity. So when SD-WAN became very popular in recent years, what they did, they repurposed this Epic EM. They used all the functionalities of the Epic EM, and they added some assurance function in the same. Assurance basically means like monitoring and all that. and they launched a new controller with the name of DNA Center. So DNA Center hardware that they are selling nowadays, it is just just a better way, just a modified Epic EM that they used to have earlier. Epic EM with the assurance function is what they are offering nowadays in the name of DNA Center. It is a very good hardware that they have offered. It has like the capability to manage the software defined local area network, like all the switches and everything we can manage, all the wireless access points and all those things we can manage from one centralized point. So DNA Center is a hardware that they offer to manage the local campus, local area network. Just like the SD-WAN solution that they offer the DNA Center as the access solution for the campus area network. Right? So Cisco offers 3 SDN solutions. For the data center network, they offer EPIC, Application Policy Infrastructure Controller. For the campus network, for the WAN, when it comes to the WAN, they offer this thing called software defined wide area network. And when it comes to like LAN, they offer software defined access. So ACI data center is handled by the controller called EPIC. SD-WAN, in the SD-WAN, we have this thing called vManage, vSmart, and vBond. These are the name of the controllers in the SD-WAN. And when it comes to the SD access, they have the thing called DNA Center. So what I'm trying to say, that if you want to have the end-to-end SDN solution in your enterprise network, purely based on Cisco, it is possible. In your data center, you can implement ACI EPIC. In your WAN, you can implement SD-WAN. And in the LAN, you can implement SD access. And you will have the end-to-end SDN solution completely based on Cisco.
So how we distinguish between the WAN and the LAN?
That is completely like another discussion. We have things such as like handoff and everything, based on which like the SDA devices can communicate with the SD-WAN. That can happen. That is possible. At the end of the day, it is just a switch. It is just a router, and they can run the protocols. They can exchange the route for the communication purpose. These controllers just allow us to do all that thing from one centralized point. But the compatibility
Why
and
Cisco
everything.
is different controllers? Why not possible for one controller?
Why it is not possible for?
Only one controller for all these things, rather than having one.
Yeah, that is what their vision is actually. So nowadays, like we can now in the recent releases of the DNA Center, we can also integrate our SD-WAN and data center solutions as well. But still, there is no unified graphical user interface for everything from one point. There is no single controller for everything. Maybe in the future, they will offer a single controller for everything, but at the moment, it is not there. We can actually go to the DNA Center and we can add our like this controller that the DNA Center can send the instructions to the vManage, and from the vManage instructions can be given to the devices. That is possible, but still there is no single controller for everything, because this came in like different times. Like this did not come like in a single time, so they still did not have not added like all these things in a central controller at the moment.
So in the lab, will you do the GUI based or the CLI based?
We'll have like VHCS both. We will have like everything regarding the WAN part as a part of our lab. SDA is a complete different thing, but from the SD-WAN point of view, we will have like everything from the SD-WAN point of view in our lab. VHCS, controllers deployment, and everything. We will not talk about like SDA and the data center Epic ACI as a part of our SD-WAN classes.
We'll only discuss about the SD-WAN.
Yes. It was just to give you the idea that apart from the SD-WAN, we also have the solution of the SD access and the ACI epic. Like we have 3 solutions offered by Cisco, and we can use all these 3 solutions just in case if you want to have end-to-end SDN solution in your campus, in your enterprise network. Right. So what is software-defined networking? SDN, software-defined networking is SDN is an approach to physically abstract the control plane from the data plane and to be able to manage all the devices from one central point. Like what I said, in a router, we have control plane, we have management plane, and we have the data plane. In case of software-defined networking, the control plane and the forwarding plane, which is what we refer to as the data plane, is going to be abstracted from each other. Like on this device, on this router, on this WAN edge router, on this V edge or C edge, whatever we call that, on this WAN edge router, like the control plane and data plane functionalities are not going to be there on the same device. It is going to be there on the different devices. So SDN is an approach to physically abstract the control plane from the data plane and be able to manage all the physical infrastructure from one centralized point. So we have an infrastructure layer, basically means like we have our infrastructure built with the help of the routers, switches and all. And then we have a controller layer from where different types of network services are running, protocols are running, and we are managing everything maybe from one centralized point. We are running different applications on the top of that controller layer so that efficiently the traffic can be delivered from one point to the other point. So SDN, software-defined networking, with the help of the software-defined networking, we can manage specifically the devices, like all the devices, all the physical infrastructure from one centralized point. So SDN is an approach to physically abstract the control plane from the forwarding plane and be able to manage all the devices from one centralized point.
Can you please elaborate with some examples on this?
Examples such as, for example, let me show you a diagram in that case.
Because I'm unable to correlate this this sentence.
It means that the devices that we are going to have, like all the devices, let's say, for example, in this topology. In this topology, we have, for example, a lot of devices that is connected on the edge of our branches, such as on site number 1, such as on site number 2, such as on site number 3. Whatever configurations it is needed to be done on these devices, we are not going to do the configurations on all these devices one by one. We are going to use the concept of controllers so that we can do all the configurations, all the management from one centralized point. All the configurations that is needed to be done, all the configurations, all the monitoring and everything that is needed to be done will be done from one centralized point. Like we will not need to take the access of all these devices one by one. Something like this. It will look something like this. For example, once we have our network up and running, once we have our all the edge devices deployed, once we have our controller deployed, once the devices are connected to the controllers and all, like once the reachability and everything is ensured, once everything is reachable to each other, connected to each other, we can manage all these things from one centralized point. So let me just show you how it will look like.
So this is one thing, management, but again the controller thing is the second thing, right? Like the routing information, everything will be done by the vSmart and
that will be discussed, that we will discuss. The point is that how the routing is going to be done, how the routes are going to be exchanged, and that thing is now centralized.
Yeah,
we still need to we still need to configure protocols such as OSPF, but I'm not going to configure protocol OSPF one by one on all these devices. I might be able to use the concept of template, and I will configure an OSPF configuration template, and I will push that template to all the devices so that OSPF gets delivered on all these devices automatically. So how the routing and everything will be done? Again, it will be done with the help of some centralized controller.
Right. Okay.
So this is how it will look like. Once everything is up and running, this is the one dashboard from where you will do everything. Yes, a control plane, management plane, data plane will be like distributed. I will say like, sorry, every device like will have their own set of like data plane, but their management plane and control plane will be centralized. Like we can have a centralized control plane and management plane. So yes, so control plane, management plane, and data plane will be different in SDN. Yes. Once you have done everything, this is what it will look like. Once you have like once you have deployed your controller, once you have deployed your S devices, this is one dashboard from where you can do everything. For example, this is like one cloud delivered dashboard. So here you can see from this centralized point, you can see all the devices that you have in your network. You can just click on one of the device and it will give the information, every information about that device in detail. For example, like how many interfaces are there, how much traffic and everything is going on. In fact, in the real time, how much traffic is going on and all, you can see all that information from this centralized dashboard. This is monitoring. This is monitoring. This is, you can do device monitoring from one centralized point. Like quality of service, like for example, TLS SSL proxy, for example, tunnels, for example, security, everything you can manage, everything you can see from this one centralized dashboard. For example, like how many times the device got rebooted and all, how many times the device got crashed and everything, all the events that have occurred, CPU utilization, everything you can monitor from this one dashboard. From this central dashboard, you can manage, you can see all the devices. From the central dashboard, you can manage the controllers. From the central dashboard, you can manage like the other controllers. We can manage like everything from here. Like from the management point of view, everything can be seen in this dashboard. So once we deploy everything in our lab as well, we will have the similar kind of dashboard, and we will add all the devices and everything from the scratch. And let's say, for example, you want to push some configurations on these devices. You don't need to do that one by one. You can just click on this and you can do everything from one centralized point, everything. You can do all the monitoring. You can do all the configuration. You have different types of tools. For example, you can do the SSH and everything. You can in fact now open the tag cases and everything from here as well. You can go to the maintenance. You can upgrade the software images. You can do basically all the things regarding the configurations and management right from here. All you need to have is the reachability from this controller to the devices, and that's it. Everything can be configured from here itself. Everything, all the configurations, all the for example, policies, everything can be configured from here.
All those devices having control plane, or that control plane has been shifted to the SD-WAN?
Your audio is not very clear yet. What did you say?
All those devices having control plane, or those control planes have been shifted to this
Centralized. They have this is management plane. This is the management plane. The control plane is centralized with the help of another controller. We have 3 controllers, and every controller will have its own function. For example, like management is centralized with the help of the vManage. Control plane is also centralized with the help of the other controller. So we have a centralized control plane as well. We will have a protocol running on the control plane to distribute the route information and everything.
So this is only for the management.
This is management plane, yes. This is one single point from where we will do everything.
And the control plane is different.
You do not get the graphical user interface. You do not get the GUI access of the control plane or the other ones. The only GUI access you get is for the management plane, and from here you can do, if you want to do some configurations, which is part of control plane, you can do it from here itself. everything. Like for example, you want to push some routing configuration, you can push the routing configurations right from here. You want to configure OSPF somewhere, you can just create an OSPF template and you can push that OSPF template onto the devices. You can just configure, you can just create, maybe you don't want to create, you do not want to configure OSPF on all the devices one by one. So what you can do, you can just configure a template for the same and you can configure that template on all the devices. Just one template on 10 devices, 20 devices, and you can see the configurations based on those template configuration that we have done. I might not have the access for the same, but yeah, you can do all the configurations and everything from one centralized point. These are like some templates that they have configured and pushed on the devices. We'll do the same as well as a part of our content. This is this statement. This is this statement that we have done. What we are doing, we are actually abstracting the control plane and data plane from each other. Like there is a centralized control plane with the help of the controller. There is a centralized management plane with the help of a controller, and the data plane is on the device itself. So the devices will just be now responsible to forward the data. Their control plane function and the data plane functions, the control plane functions and the management plane functions are going to be centralized by some controller. So Cisco SD-WAN represents the shift from an older hardware-based model of the legacy WAN to a secure software-based virtual IP fabric overlay that runs over standard network transport services. Means like we can have our different types of devices. We can have our controller. We can connect them with the help of traditional transport such as MPLS, 4G LTE, internet. They will form some sort of connections to each other, and we will be able to manage everything from one centralized point now. So SD-WAN represents the shift from the older hardware-based model of the legacy WAN to a secure software-based virtual IP fabric overlay that runs on the top of the net. Standard transport services such as internet, MPLS. We don't need to have a complex. Earlier, what we used to have, for example, a high speed, let's say, for example, MPLS link and a low speed internet link for the backup. Nowadays, you don't even need to go for a dedicated MPLS connection. You can just have like SLA based internet. You can have like 4G LTE. You can use this traditional, like you can just use traditional network services such as internet, 4G LTE to do all the management or to do all the interconnection to each other. And that is why people nowadays are saying that SD-WAN is going to replace the MPLS and all, but that is not the case. The use case of the MPLS is completely different than of the SD-WAN. So not anytime soon the MPLS is going to be replaced by the SD-WAN. That's not going to happen. MPLS, internet, and 4G LTE, these are just the transports that we are going to use to connect our edge devices together, that we are going to use to connect our edge devices with, let's say, for example, controllers. So this is how the graphical user interface looks like for the SD-WAN. And similar type of interface you might see, for the DNS and from the user interface point of view. I can also show you like how this DNS enter looks like. So this is like one of the controller that they offer. This is one of the controller. This is one solution that they offer. Cisco SD-WAN solution to manage all the WAN edge devices from one centralized point. Similar to that, they also have the DNS enter solution. They also have the SD access solution, which looks something like this. Let me show you. We'll talk about these things like next, like what is SD-WAN, what are the functions that it offers. Just to give you the idea, the user interface of the SD-WAN looks something like this. Like once we have set up everything, this is the centralized dashboard from where we will be doing all the management and everything. Management, configurations, policy, everything from the centralized point. And this is how the user interface of the Cisco DNS Center looks like. This is a user interface of the Cisco DNS Center. Similar kind of interface. So like this DNS Center is basically managing total 62 sites, 121 devices, all from one centralized point. I can click on this site. It will show me from the design point of view where those sites are. I can click on the device. I can click on, like I can basically navigate in the hierarchy, like where that particular device is actually. And we can manage like all the devices and everything from one centralized point. This is like the user interface for the DNS. Right, so we can apply a variety of policies from here. We can do the configuration, we can create our fabric, we can do like a lot. We can also do the monitoring and everything like the similar kind of thing that you see here in the vManage in the SD-WAN solution. Similar kind of thing you see here in the SD access solution as well. This is for LAN and this is for actually WAN. This is for WAN, this is for LAN. And it is possible in DNS Center, it is possible that nowadays you can actually, it is possible that in DNS Center, now you can integrate all these external services such as our vManage. We can actually add our vManage in the DNS Center so that DNS Center can also give the instructions to the vManage and vManage passes those instructions to the WANS devices. So that is also possible. So no need to worry about the DNS Center anymore. But the point is that we do have different solutions for the LAN and WAN. The solution for the LAN is called the DNS Center, and the solution for the WAN is called like SD-WAN based on Viptela. So Viptela SD-WAN. Right. So DNS Center is specifically for the LAN. DNS Center is specifically for the local area network, from where we can manage everything from the local area network from the LAN point of view. All the devices and everything, like all the topology and everything, can be seen and managed right from the DNS Center. However, from when it comes to the WANS device management, that can be done with the help of the vManage. And same goes for the ACI for the data center. We do have similar type of user interface for the ACI as well. That is going to manage the data center infrastructure. Right. So this is all the basics that we need to know from the like SD-WAN point of view. What are the challenges in the traditional WAN? What is SDN solution? Different SDN solutions offered by Cisco, and like we'll talk more about the SD-WAN solution tomorrow. We'll now like talk about like, is it virtual, is it physical, how to deploy the controller, how to deploy the devices and all. We'll talk about all that thing like tomorrow. Right. So we'll talk about this other things from here tomorrow. Any questions if you guys have, you can ask now.